Good morning, all of you. How are you all? So, in this session, let us have a talk. Fourth basic point, that is ions. So, in this one, we are going to discuss what is meant by ion, classification of ions, and some number of examples of ions. Get ready, students. Let us start. Ion. What is meant by ion? Ion is a charged particle or charged species, either positive charge or negative charge. So generally ions are found by the gain or loss of electron by the element. Gain or loss of electrons by the element. So ions are charged species, either positive or negative. For example, sodium ion, Na plus sodium ion, Cl minus chloride ion, sodium ion Na plus, chloride ion Cl minus. So these two are considered as ions because of they contain charge, either positive or negative. In case of chloride, it has negative charge. In case of sodium ion, it has positive charge. Ions are nothing but charged particles, charged species, either negative or positive. Next one. So generally ions are formed by gain or loss of electrons. Here sodium gives sodium ion by the loss of one electron, whereas chlorine gives chloride ion by the gain of one electron. That means general definition, general statement regarding to formation of ion, that is generally ions are formed by the gain or loss of electron by the element. Is it clear? Right. Now, types of ions. How many types of ions are there? Or on what basis ions are classified? Right. Make a note of it. Ions. Ions are very important to write chemical formulas in higher and in further classes, in higher classes, whatever it is. So ions are help to write chemical formula. Chemical formulas help to write equations. So to write number of equations yourself, we need to understand chemical formulas. To write chemical formulas, we require ions. It's a very important topic. Ions. Types of ions. Types of ions. Ions are classified into different types based on different points. Based on charge, based on charge, based on charge, and based on atoms present in ion. Based on atoms. Based on charge. Based on charge, ions are classified into two types. Based on charge, ions are classified in two types. Cation and anion. So cation means positively charged ions. So later on, let us discuss in detail. No need to worry about that. Just draw the flowchart. Ions are classified into different types based on different kinds of points. Based on charge, these are classified two types: cation and anion. Based on atoms, these are classified into two types: simple ions, and compound ions. Compound ions. Simple ions also called element ions, and compound ions also called polyatomic ions. Polyatomic ions. Polyatomic ions. So this is a clear picture of types of ions. Ions are classified different types based on charge and based on atoms. Based on charge, these are two types: cation and anion. Based on atoms, two types: simple ions and compound ions. Compound ions also called polyatomic ions. So let us discuss one by one in detail. Okay, right. So let us have a talk cation first. What is meant by cation? What is meant by cation? Please make a note of it. I am going to give very important points. So never get or you never seen in the books. So I am going to give very important points regarding to cation. Write down cation. Cation means positively charged particle. Positively charged particle. Positively charged particle. Positively charged particle. It is found by the loss of electron or electrons. Generally cation is found by loss of electron or electrons. Loss of electron or electrons. Next one. In case of cation, in case of cation, number of electrons are less than protons, or number of protons are greater than electrons, because of, so cations are found by the loss of electron. So if it is lose an electron, the number of protons are increases and number of electrons are decreases. So that's why in case of cation, number of electrons are lesser than number of protons. Next point. In case of cation, size of size of size of cation is smaller than that of its parent atom. First of all, please make a note of all the points. I will explain one by one with number of examples. So cation, positively charged particle. It is obtained by the loss of electron or electrons. The number of electrons in cation lesser than the number of protons. Next one, size of cation is always smaller than that of its parent atom. Next one, next point. Next point I am going to write here. Next point. Next point. I will write here. Next point. Generally, cations are found by metals and hydrogen. Metals and hydrogen. Next one, the formation of cation is endothermic in nature. Endothermic. Please copy all these points. Later on, let us discuss one by one these points in detail. First one, generally cations are positively charged particles. They are obtained by are found by the loss of electron or electrons. In case of cation, number of electrons are lesser than number of protons. In case of size of the cation is always smaller than its parent atom. Next one, formation of cation is endothermic in nature. Generally, cations are found by metals and hydrogen. Okay, right. So let us take examples, and with the help of example, I will explain all the points. Right. Right. Generally, cations are found by the loss of electron or electrons. Example: sodium, magnesium, aluminum forms cations because of these all are metals. How can you say that these all are metals? Listen carefully. I would like to give one simple point. So metals, generally metals possess valency electrons 1 or 2 or 3. Please make a note this point. So these all are metals. How can you say that? In case of sodium, only one valence electron. Magnesium, 2 valence electrons. Aluminum, 3 valence electrons. If the element has valence electron 1 or 2 or 3, these are generally considered as metals. Some exceptions also there. Metals. So cations always found by the metals. So here sodium, atomic number 11. Sodium want to attain neon configuration because of, I said, each and every element in the periodic table always try to attain nearest noble gas configuration by the gain or loss of electron. Here sodium atomic number 11. It want to attain neon configuration because of neon is the nearest to sodium. So if it is lose one electron, it gets neon configuration. So that's why sodium has tendency to lose electron always. So sodium, by the loss of one electron, gives sodium ion. Sodium ion. So the positively charged ion is called cation. So cation is found by loss of electron. I said no, cation is found by loss of electron. And generally cations found by the metal because of sodium is metal. How can you say that sodium is metal? Listen to me. Sodium electronic configuration 1s2, 2s2, 2p6, 3s1. First shell, second shell, valence shell. How many valence electrons? 1. If the element has valence electrons 1 or 2 or 3, these are considered as metals. So sodium is a metal. So form sodium ion by the loss of electron. So generally cations are positively charged ion. These are found by the loss of electron. Generally these are found by the metals and hydrogen. This is the formation of sodium ion. Next point. Next one more point I said. Formation of cation is endothermic in nature. Endothermic. What is endothermic nature? What is exothermic in nature? Endothermic in nature, so those reactions in which energy is utilized, energy is absorbed, is called endothermic reaction. Exothermic reaction means those reactions in which energy is given out. During the process, energy is given out. Is called exothermic reaction. So formation of cation is endothermic in nature. I said formation of cation is endothermic in nature. How it is possible? Let us look into that. Let us look into that. So let me draw the shell representation diagram of sodium. Let us use the nucleus of sodium. It has 3 shells. First shell, second shell, and third shell. And third shell. In first shell, 2 electrons are there. If you look at the electronic configuration of sodium, then you will get sodium 1s2, 2s2, 2p6, 3s1. 2 electrons, 1, 2, 3, 4, 5, 6, 7, 8. Second shell, 8 electrons. First shell, 2 electrons. Third shell, only 1 electron. 1 electron. Right. So, to convert the sodium into sodium ion, or in order to attain nearest noble gas configuration of neon, it should lose 1 electron. To lose an electron, we need to give energy because of, so nucleus consists of protons and around the nucleus electrons are revolved. Electrostatic force of attraction existed between the oppositely charged particles. Protons always have tendency to attract electrons towards their self. So that's why due to presence of electrostatic force of attraction, if you want to remove the one electron from valence shell of an element of an atom, valence shell of an atom of element, we need to provide energy. So if you want to remove this electron, we should give energy. If we give energy, then it's a very easy to remove electron. So that's why here we are giving energy. So energy is utilized by the electron to overcome the force of attraction existed between the electron and proton. So that's why the formation of cation is endothermic in nature. Is it clear? Because of atom required some amount of energy to remove its electron. So that's why it is endothermic in nature. Next one. Next one. Is it clear to you? Next point. So cation, size of the cation always smaller than that of its parent atom. Listen to me. If you remove one electron, it gets positive charge. If you remove one electron, it gets positive charge. So let us assume this is a sodium ion. First shell, second shell. So there is no third shell because of if you remove electron, the shell will be cancelled out. Only two shells are remains in the sodium ion. 1, 2, 3, 4, 5, sorry, 4, 5, 6, 7, 8. This is the sodium ion. This is the sodium atom. So if you look at these two, then you will get clarity. So which one is the smaller than? So sodium ion is the smaller than that of its parent atom. So this is a very important point. So cation always smaller than that of its parent atom. Parent atom means from which it is obtained. Sodium ion is obtained from the sodium atom. So sodium ion is always smaller than that of sodium atom. Is it clear? So what is the reason behind the size decrement in case of sodium ion? Two reasons. One is increment in proton density. Please make a note of it. Increment in proton density. Number of protons are increases in the nucleus. So that's why the protons strongly attract remaining electrons toward itself. So then shells are come close together. Shell will be compressed. Then the size of the ion decreases. So second point, in case of sodium, not in all the atoms, in case of sodium, so shell will be cancelled out. So that's why it has two shells, it has three shells. So that's why shell will be cancelled out. So that's why there is no shell. So that size of the atom, size of the ion also decreases. Two reasons: increment in proton density. Next one, decrement in number of shells. Decrement in shells. Decrement in shells. So, so 5 or 6 points I said regarding to cation. So let us recall one by one. Cation. Cation means positively charged ion. Generally, cations are found by the loss of electron or electrons by the element. So cation size is smaller than that of its parent atom. Next one, cation's formation is endothermic in nature because of, so cation is formed by loss of electron. So if you want to remove the electron from outermost shell of an atom, we need to provide energy. We are giving energy, atom is gaining energy. If the substance or atom or anything absorb energy, so that is called endothermic process. So these are. So generally metals and hydrogens will give cations. So these are few words regarding to cations. Is it clear to you? Please remember these all the points. Cations, positively charged ions, formed by the loss of electrons. In case of cation, number of electrons are lesser than number of protons. In case of cation, size of the cation is always smaller than that of its parent atom. In case of cations, or during the formation of cations, these are endothermic in nature. Okay, right. Next, one more point. Generally, cations are found by the hydrogen and metals. So how will you know that those, that means how will you come to know that which are metals or non-metals? So if the element has valence electrons 1 or 2 or 3, they generally consider as metals. Is it clear? Right. So these are the few words regarding to cations. Next one, anions. Let us have a talk about anions. Right. Anions. Anions. Write the points, nearly 6 points, same as cations. Anions are negatively charged particles. Negatively charged, negative charge. These are found by the gain of electrons, gain of electron or electrons. Next one. In case of anion, number of electrons are greater than number of protons. Next one, the size of the anion, always, size of the anion always greater than its parent atom. Parent atom. Parent atom. Next one. Formation of anion is exothermic in nature. Exothermic in nature. Very important. Exothermic in nature. Next point. Generally, anions are found by non-metals, non-metals and hydrogen. So what are non-metals? Non-metal means, write down. Non-metal means those elements consist of valence electrons 5 or 6 or 7. These are called non-metals. So make a note of all these points. Anions means negatively charged particles. They are obtained by the gain of electron or electrons. In case of anions, number of electrons are greater than number of protons, and the size of anion is greater than that of its parent atom. So formation of anion is exothermic in nature. So generally anions are found by non-metals and hydrogen. Okay, right. So what are non-metals? Those elements are having valence electrons 5 or 6 or 7 considered as non-metals. Right. Right, very good. Now let us discuss formation of anions. Generally, non-metals are found by the anions. Listen to me, I would like to write non-metals here, so please make a note of it. Selenium, carbon, iodine, phosphorus and sulfur, bromine, hydrogen, nitrogen, oxygen, fluorine and chlorine. So these are non-metals, please remember. Non-metals. So anions are generally found by the non-metals. Let us take very simple examples like chlorine. Chlorine atomic number 17. So chlorine wants to attain argon configuration. Argon configuration because of argon is the nearest noble gas of chlorine. Right? So to attain argon configuration, it should gain one electron. It required one more electron. It required because of its 17 is 18. So if it is gain one electron, it will be equal to argon. So chlorine wants to attain argon configuration. So that's why it has tendency to gain electron from others in order to attain argon configuration. So then chlorine by the gain of one electron gives chloride ion. Chloride ion. Right? Chloride ion. Right? Chloride ion. Next. So let us look into formation of chloride ion. Let us discuss internal structure of chlorine and let us understand how to chlorine gets chloride attained argon configuration. Look into that. Chlorine atomic number 17, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, sorry 3p5. First shell, second shell, three shells are there in chlorine. So let us draw the internal detailed structure of chlorine. Chlorine 1, 2, 3 shells are there. First shell 2 electrons, second shell 8 electrons, third shell 5 electrons. So 17. So it's formed to attain argon configuration. So it should gain one more electron. If it is gain electron, say last shell, case of chloride ion, 3 shells are there. Let me draw in detail. Wait a minute. Chloride ion, nucleus, first shell, second shell, third shell. So outermost shell will be 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Second shell also 8. 1, 2, 3, 4, 5, 6, 7. Second shell 12. Right? Gain of electrons taking place. If number of electrons increases, the attraction between the protons and electrons somewhat decreases, because of, in case of anion, number of protons are lesser than number of electrons. So that's why, due to decrement in proton density, shells are move away from the nucleus and size of the anion increases. So the size of the anion always greater than its parent atom. So this is a formation of cation and anion. And in next session, let us have a talk simple ions and compound ions. Till then, keep learning, my dear. Thank you. Have a nice day. Take care.